So water is life. It's essential to our entire existence. But freshwaters, they're changing, and they're changing largely because of human impacts, whether that be pollution, climate change, changing the land around rivers and lakes. And we need a way to be able to measure what our impacts are on freshwaters and how to reverse them. In our article, we introduced this idea of chemical diversity and how tracking the chemical diversity in water can provide us with a way to understand why water is changing and how we can reverse those changes. So what is chemical diversity? Well, I'm gonna scoop up some water here, and invisible to our eyes inside of this water are going to be 5, maybe 10,000, maybe 20,000 different chemical compounds, all based around carbon. These compounds are called organic matter, and organic matter comes from the dead remains of the plants and animals alongside waterways, but also from the organisms, fish and algae living inside of waterways. So measuring chemical diversity can provide us with a really powerful way to track how waters are changing because of climate change. So there's a really great example over my shoulder of how we can track climate change impacts on waters. So look at all of these, take all of these coniferous trees we have here. Those are the ones with needles that you see along the side of the river. Now, because of climate change, we're expecting more deciduous trees. These are the ones that drop their leaves in the winter to grow around waterways. Coniferous trees are going to produce very different compounds than those deciduous trees. And so once those compounds enter water, compounds from the deciduous trees might do different things than the compounds from the coniferous trees. So by measuring the chemical diversity in the water, we can track these climate change impacts and their implications for the things we care about in water, like drinking water quality.